scientist, top-ranking scientist in India, as done by the ministry. So we also congratulate from on behalf of CSTS-GUWAHATI, we wish him all the best for his future endeavors. And before we start, I would like to request Dr. Jutika Devi to kindly felicitate him with a Fulam Kamsa. Thank you, Sodri, and I'd like to request you to kindly proceed for your presentation.
Good afternoon, one and all present here. Good afternoon, one and all present here. Myself, Vishwajit Chaudhary. I am an associate professor in the Physical Sciences Division of AICTE. It is basically a central government institute funded by the Department of Science and Technology. So I have chosen a topic that is I believe most of you have heard about nanomaterials or nanoscience or nanotechnology, this thing. So I'll be speaking very in a layman language or in a very simple way, these nanomaterials or nanostructured materials and their characterization, means how to study them. So if you have heard about nanomaterials or nanostructured materials, we simply understand there is one term, that is nano. What do you understand by nano? That is basically anything that falls in the range of 1 to 100 nanometer. So that is quite small. If we say that it is 10 to the power minus 9 meter is equal to 1 nanometer. So first, simply, if I take my hair, that if I cut it right vertically million times, then we can get nanometer. So it is that small. Now we know we are surrounded by many things, many objects or many devices that actually has the basic unit or basic structural formation that is coming from nanomaterials. For example, I will speak about that later on, but in the beginning, those who have not heard about nano or nanomaterials, that is why I will be briefing about its type or how to define it. Usually we know that now all of you use mobile devices. Now these mobile devices, nearly 10 years back, you had only black and white. It did not have color, it cannot store anything. But now you have mobile that can store up to 120 GB data, right? So how that could be possible? You are not carrying a mobile of this size. The mobile size is similar. But what is increasing? Its storage capacity. What we could not do, now we can hold many things. We can keep many files, many movies, songs, right? Everything we can do with our mobile. So how can be stored? Usually earlier, for every bit of storage of knowledge, suppose that required 0.1 millimeter of area. Now in 0.1 millimeter, you can store many information, many data. So that is the contribution of nanoscience and nanotechnology. So without delay, I will first go to how small is nano. Okay, I think without mic also you can hear me, yes, right? Okay, so I will be moving here and there, that is why I am asking. So how small is nano? When we say nano, that is usually we define anything that falls in 1 to 100 nanometer of ranges. Now in 1 to 100 nanometer of ranges, what are the things that fall? We have polymer. This institute, for example, where means it is on what? Petrochemical, and they also deal with polymer and other materials. So these polymers
are in that range. Then you have some biological system, for example DNA, viruses, that has size range that is in the nanoscale dimension only. So there are basically two. One is man-made. Man-made means that is synthetic, we prepared it. And one is which is available. For example, our DNA, that is not man-made, right? That is biological nanostructures. It is DNA, protein, glucose, viruses, COVID viruses. I will give you the picture of COVID viruses later on. So these are all available in nature. But something which are man-made, these are suppose polymer. Any nanocomposite material of polymer that is in the nano range. Then quantum dot. Quantum dot, I will define quantum dot later on. Quantum dot is basically something that has a size of only 1 to 2 nanometer. That is that small. I will go to that. So these are all some materials which fall in the range of nanoscale dimension, 1 to 100 nanometer, both synthetic as well as man-made. Now, before going to the understanding of nano from the perspective of general physics or from general chemistry, so I will give you a brief idea where it's the existence of nano does not come in 1 to 100 years in that range, but in that years. But if we go much before, in Roman, most of the churches they use this kind of painting or this kind of in glasses, they coat something, they paint something. Its color still retain this day. Later on, when scientists tried to find, okay, how this can be happening that its color still is fresh, they scratched out and they found that each of this color that is made up of some metal nanoparticle. These are silver, these are gold. When they found how did they know that these are nanoparticles? They saw under a microscope. But that is not a simple microscope that many people see in higher secondary classes, right? We see the blood sample or something. That is not that microscope. These microscopes are called electron microscope. That is, we do not see like this, but electron give us the picture. So I will go to that. So after that, this is Lycurgus cup in ancient Roman time. So these cups are basically used. So what is the fascination of these cups? You can see there are two colors. One is green and one is red. So how this is happening? In one, the light. For example, this is the cup. This is the cup. In one, what they are doing, they are shining the light from the front. And in another, they shine the light from the back side. Okay, so when they shine the light from the front side, obviously it will be reflected. When this reflection occurs, they saw green coloration. But from the back side, when they shine the light, they found it is red in nature. You have also seen something when you keep like this and when you shine torch, you will see it is red type of things. But in there, because some reflection has been occurring, and that we see the color differences in different material. So this Lycurgus lab, so they found that these are also some metal nanoparticles which are coated over there. When light falls, they interact with light and give us different color behavior. Is it from the front side or from the back side? We get different colors. The third picture is Tipu Sultan's sword. Now Tipu Sultan's sword, later on when they took out a fraction of the Tipu Sultan's sword and tried to analyze, because this sword was said that it is very light, but at the same time it is quite hard. Okay, so when they tried to find out, they found that these are made of iron carbide particles. But when they made, they did not know that they are putting some iron carbide or something like this, because at that time there was no such equipment or no such experimental facility that can analyze the composition of a material. Okay, so when they find that these are small particles of iron carbides are there. So there are lots of examples in history where people used it, but people did not know that its size could be that strong. A simple example could be, for example, gold. We know gold color is normally ornaments most of you wear. So these are yellow in color, we basically know. But this gold, when its size is too small, That means a gold, if you crush it to a very small sizes, it shows different color. It may show red color, purple color of this thing. Okay, so these are all the fascinating attributes of, we can say, of nanomaterials or nanostructured materials. Now, modern definition of nanomaterials. Now, just I am asking, anyone do you know who this man is? If anyone is from physics, ask. Have you ever seen this man anywhere? For example, Einstein is said in physics that he was the man, or he was the scientist of 20th century or so. He is the man, he is the scientist in physics of 21st century. His name is Richard Philip Feynman, R.P. Feynman. Mostly he is known as Richard Feynman. Okay, he made some remarkable statement in his lecture of 1969 in Caltech, that is California Institute of Technology. In Caltech, he made some remarkable statement, that is in 1959. At that time also, no nano word came into existence. Nano came, this term itself came much later. Okay, there is no term like nano, but he made a statement, the basis of which can be taken as the revolution or the starting of the thinking of nano, that the things can be made up to that smallest dimension. What he said, you have seen the something I have kept in rectangle, red rectangle, right? So what is the statement there? Why cannot we write the entire 24 volumes of Encyclopedia Britannica on the head of a pin? Okay, so Encyclopedia Britannica you have seen, I believe. So these are large volumes, 24 volumes of Encyclopedia Britannica. One volume, it contains more about 1200 pages or something. So obviously scientists will be quite confused that how somebody can write not even one which contain 1200 pages, maybe 30,000 words or something like that, 24 volume of Encyclopedia Britannica on the head of a pin. So definitely everybody will be confused that why Feynman made this statement. And he is not that kind of a person that somebody will think that he is a fool and that is why he is making that statement. Because at that time he was at the forefront of physics, means one person of that century in physics who made this comment. So how can it be possible? He gave the answer also. He gave the answer also. He said, you need to write each of your letter, okay, in Armstrong unit. Armstrong, we know the smallest, right? Unit we can go up to, even smaller than nano. So if you write, for example, A we know that if I write A, that will be what? About 2 centimeter that sizes. So instead of that, if you write A in atomic dimension, in Armstrong unit, then you can write. So at that time again people got confused. Because we cannot see micron unit, 10 to the minus 6, even not in 0.1 centimeter. If I ask you, this is 0.1 centimeter, can you see from there? No, you cannot. So this is 10 to the power minus 10 times smaller. So how can somebody write something in Armstrong unit? So this statement, although he made, for many years it was blank, because nobody has any tool to proceed with the writing of these things or understanding the concept of nano. So what happened? That was in 1959. In 1981, so it is nearly 30 years. Okay, 1981, IBM you have heard, right? All the computers, IBM, these two scientists are from IBM. They developed something. Actually, they were related with the computer, these things, all these things. They developed something that is called scanning tunneling microscope. They devised one microscope. Microscope was existing from a long time. That is basically light microscope which we normally use in biological this thing. But that is not that microscope. These two gentlemen's name was Binning and Roeder. They got Nobel Prize in physics for the discovery of this machine, that tiny machine you are seeing, right? That machine they named scanning tunneling microscope. Although they prepared this, they discovered this machine, they were also not thinking that how means what are the uses of this instrument or machine, right? They just worked on it and they found that it is fascinating and they got the Nobel Prize. But what basically they did? So this is a research paper for which they got the Nobel Prize, tunneling through a controllable vacuum gap. This is this you have seen. This is written IBM. You see, this is IBM. But these are not with a pen. These are all atom. These are all atom. These are spike-like things, as you have seen. These are atom. Okay. So before again proceeding, I'm asking means how many are you from science background? Means is it okay? I'm going. Yes. Okay, fine, thank you. So these are all, as you have seen, these are atoms. So which atoms are these? These are xenon atoms. Okay, all these are xenon atoms. That is in 1989. Again, you see, 1981 they discovered this machine. After 8 years of gap, again scientists from IBM they wrote IBM. But at that time people must be thinking, so what is the use? Suppose instead of writing like this, if you wanted microscope to write something, it is of no use, right? At that time. But later on people realized the importance of it. See, they wrote IBM with 35 xenon atoms over a nickel surface. Okay, over a nickel surface, for example, similar, they are not writing pen, they use the machine. So the machine control the writing. Okay, now you know everything is now coming what? AI, artificial intelligence. So there you can say that with this machine scanning tunneling microscope, they wrote the IBM. They did not stop. Later on, so this is actually famous book in physics. Later on what happened? This you can you see this is circular things, right? All and in between red color things you have seen circle kind of. So this like the teeth type structures that is circular, that is nothing but that is called quantum coral. These are iron atoms only. So you can see earlier they used only 35 xenon atoms because it is not easy to manipulate. This is called atomic manipulation. For example, we know, suppose these all atoms are on position. To write something, what you have to do? You have to pull out this atom from its original position and keep it somewhere else. It is not that much easy because we know all atoms are attached with the surrounding atoms, right? Because these are not free, all atoms are attached with another surrounding atom. So with the machine you have to pull out that atom and then you have to place it somewhere to write in this manner. So this is called, they call quantum coral. So from 35 xenon atoms, they increased their system to 48 xenon atoms and they found this kind of circular kind of structures. So then they found that they can manipulate atoms. You see, we can even not see atoms, right? So now go back to the statement of Richard Feynman, what he said in 1959. He said, can we write Encyclopedia Britannica on the head of a pin? Now people are realizing it can be possible because now people can manipulate atoms. That means if atoms are on the same in a periodic position on its own side, they can keep one atom from this position, they keep to another position using machine. That machine is scanning tunneling microscope. So these are the papers basically related to these works. Now this is how they actually run. It is not possible. For example, on a system, atoms are like this only in the figure, that one A. Okay, this one. This is haphazardly present. See, with the machine they pulled like this. I first they wrote, then B they started, finally they completed all this IBM. Now it is horizontal view. Horizontal means from this side you are seeing. If I see like these things, it looks like this. These are all atoms. This is how atoms means it looks like when they found in this manner. Earlier they saw like this, but in this way if I see, then it looks like teeth kind of structures, spike type kind of structures. Okay, so this is what they found. Now going ahead, I'll give I saw here one video. Now you see that is in year 2013. Now coming to the modern time, 1959, many years is gone. They first wrote IBM, okay, only writing, then this one. Now I'll play this. Sorry, video to play no hobo. It was a video. Oh, it was a like a mix আচ্ছা মই যেটো ভিডিও এতিয়া মই এখন স্ক্রিন দেখালো সেটো আসলে এটা ভিডিও হয় হেতু ভিডিও হৈছে এটমেৰে বনোৱা ভিডিও এটো এবিলাক সব এটম এটা এটা এই সিনেমাখন আটাইতকৈ পৃথিৱীৰ স্মলেষ্ট সিনেমা যিখন নেকি এটমেৰে বনোৱা দেই 5000 টা এটম আইবিএম যেনেকে লিখিছিলে তেওঁলোকে প্ৰথম স্ক্ৰিনশ্বটে লৈছিল তেনেকে লিখিছিলে পিকচাৰ লৈছিলে তেনেকে 5000 খন এনেকুৱা তেওঁলোকে স্ন্যাপ লৈছিল এবিলাক গোটেইখিনি ৰাউন্ড যিখিনি আছে আটাইখিনি এটম লৈ পেলাই তেওঁলোকে এখনৰ লগত সিখন লাহেকে মিলাই পেলাই এই ভিডিওটো তেওঁলোকে তৈয়াৰী কৰিছিলে এটো খুব বেছি 1.5 মিনিটৰ ভিডিও ইউটিউবতো আছে এটো আইবিএমৰ যেটো ওয়েবসাইট অফিচিয়েল ওয়েবসাইট তাতো আছে এটো সেই মুভিখনৰ নাম হৈছে এ বয় এণ্ড হিজ এটম আৰু এটো ইমানেই ইন্টাৰেষ্টিং তেওঁলোকে কেনেকৈ বনাইছিল সেটো আছে মানে ভাবিলে আচৰিত লাগিব এটা যে এটম দি পেলাই তেওঁলোকে এটো জপিয়াই আছে এই ভিডিওটোত মানে কি হয় এই লৰাটোৱে মাৰ্বল এটা বল এটা খেলি থাকে গোটেই ভিডিওটো ইয়াতেই নহল লৰাটোৱে বল এটা খেলি থাকে সেই বল কিটো গৈ পেলাই লাষ্টত এনেকে উঠি পেলাই কি লাহে লাহে ওপৰলৈ যায় আৰু কমপ্লিট আইবিএম টো পিছত ওলাই যায় ভিডিওটোৰ লাষ্টত তো এইখন হৈছে মানে পৃথিৱীৰ আটাইতকৈ স্মলেষ্ট যিখন নেকি মেচিনেৰে আৰু এটম দি পেলাই তেওঁলোকে বনাইছিলে মানে ইয়াৰে এক্টৰ বিলাক হৈছে এটম তো তেওঁলোকে কিমান পৰ্যন্ত পাই গল যে তেওঁলোকে এতিয়া ভিডিওই বনাই দিব পাৰে এটম দি পেলাই দেই এটো আইবিএম মতে কৰে 5000 ইয়াত মোৰ মেনশন আছে 5000 টা এটম লৈ পেলাই তেওঁলোকে কৰিছিলে এটা বস্তু মান চালে আচৰিত লাগে তেওঁলোকে আৰম্ভ কৰিছিল 35 এটম দি পেলাই লাহে তেওঁলোকে 5000 এটম মানে ঘূৰাব পৰা হৈ গল মানে এনেকে ঘূৰাব পৰা হল যদি এনেকে সন্মুখত চাও যেটো বস্তু দেখাই নাপাও আমি এনেকে হাতেৰে কিবা এটা বস্তু চুব পাৰো কিন্তু এটম দেখা নোপোৱাটো মেচিনেৰে তেওঁলোকে ইফালৰ পৰা আনি তাত থলে তাৰ পৰা আনি ইয়াত থলে তেনেকে মেনিপুলেট কৰি পেলাই ইমানখিনি এটা কাম কৰিব পাৰে ইমানখিনি ডেভেলপমেন্ট সায়েন্সৰ হৈ গৈছিল তো ভাবিলে আচৰিত লাগে ইয়াত এটা বস্তুতে ৰিচাৰ্ড ফাইনমেনৰ যেটো কয় দূৰদৰ্শিতা মানুহে তেনেকুৱা ধৰণৰ কোৱেশ্চন বিলাক এটা সময়ত এবসাৰ্ড লাগে ন যেনেকে এনেকুৱা লাগে যে যেতিয়া প্ৰথম মুনলে গৈছিল বা প্ৰথম যেতিয়া মানুহ স্পেচত গৈছিল যে মই ওপৰলৈ গৈ যাম যেটো নেকি এক্সিস্টেন্স নাছিলে সেই সময়ত মানুহে বৰ অদ্ভুত ভাবিব কেনেকৈ ওপৰলৈ যাব ৰিচাৰ্ড ফাইনমেনকো একদম তেনেকে ভাবিছিলে সেই সময়ৰ বিজ্ঞানী বিলাকে যে অদ্ভুত কথা কিছুমান কৈ থাকে মানুহ ইমান কিটা বস্তু পিনত লিখিব পাৰে নে কিন্তু সেই বস্তুটো সেই 1959 ৰ পৰা মানুহে প্ৰগ্ৰেছ কৰি 2013 লৈ এই অৱস্থা পাই গল এইখিনি আহি গল আসলে এইখিনিৰ ইম্পৰ্টেন্সটো ক'ত ইম্পৰ্টেন্সটো হৈছে ইয়াত এই যে মই যে অলপ আগতে ক'লো যে মোবাইলৰ যে আমাৰ যে কেপাসিটি বাঢ়ি গৈছে সেই যে মই ক'লো মেমৰি ডাটা সেইবিলাক সব এটমিক হেৰিত লিখে সেইটোৱে বস্তুটো আগতেতো নাছিলে আজিৰ পৰা কেইবছৰ মানৰ আগতেতো মোবাইল ব্লেক এণ্ড হোৱাইট কোনো ষ্ট'ৰেজ বুলিবলৈ বস্তু নাই কিন্তু এতিয়া যিখিনি ষ্ট'ৰেজ হয় সেই অকণমান চিপতে ইয়াতকেও কম হ'ব চাগে চিপৰ চাইজটো তো তাত ডাটাটো কেনেকৈ ষ্ট'ৰ কৰিব সেই ডাটাটো এনেকুৱা মেচিন দি কৰে তো আগতে যদি মই জাষ্ট চিম্পলি কৈছোঁ 35টা এটম লৈ যদি ডাটা ষ্ট'ৰেজ কৰিব পাৰে এতিয়া সেইখিনি জেগাত 5000টা ভৰাই দিব পাৰে তেওঁলোকে গম পাইছেনে তো সেই তেনেকৈ তেওঁলোকে ইমপ্ৰুভ আৰু প্ৰত্যেকটোৰ এটা এটম মানে এটা মেমৰি আৰু সেইখিনি আমি কিহত কওঁ আমি মেগাবাইট কওঁ কিলোবাইট কওঁ সেইখিনি নহয় জানো তো 1000 মানে মেগাবাইটৰ পৰা আমি তাৰ পৰা ওপৰলৈ গ'লে গিগাবাইট কওঁ সেই মেগাবাইট এটা এটম মানে 1 মেগাবাইট ষ্ট'ৰেজ কৰিছে কোনোবাই কিবা এখন ফটো ষ্ট'ৰ কৰিছে সেই 1 মেগাবাইট কেপাচিটি লাগিল তো তেনেকুৱা যদি 10000 মেগাবাইট তেওঁলোকে কৰিব পাৰে মই এখন হেৰি দেখুৱামগে কিমান হ'বগে আৰু এই এডভান্সমেন্টটো দেখুৱা আমাৰ যিখিনি হাৰ্ড ডিস্ক আজিকালি লওঁ হাৰ্ড ডিস্ক বিলাক কিমান ইমান পকেট সাইজৰ হৈ গৈছে হয়নে 1 TB হাৰ্ড ডিস্ক জাস্ট মানুহে ফ্ৰন্ট পকেটত লয় ইমান কম লৈ যাব পাৰে মোৰ মনত আছে মই যেতিয়া PhD হাৰ্ড ডিস্ক কিনিছিলো ঢেৰ ওয়্যাৰ লাগে প্ৰায় দুডাল তিনটাৰ ওয়্যাৰ লাগে মোৰ হাৰ্ড ডিস্ক চলাবলৈ ইমান খন ইটাটোৰ সমান ডাঙৰ তাৰ আগৰ IBM এ যিখন হাৰ্ড ডিস্ক কৰিছিলে মাত্ৰ MB আছিল ইমান প্ৰকাণ্ড হাৰ্ড ডিস্কখন সো হেতু কি কয় যে ডাইমেনশনটো সৰু হৈছে কিন্তু কেপাসিটিটো বাঢ়ি গৈছে এইবিলাক গোটেইখিনি হৈছে ন্যানো টেকনলজি মানে স্মলেষ্ট ডাইমেনশনৰহে কন্ট্ৰিবিউশন আৰু এটা এইখিনিতে বস্তু কম এইখিনিতকেও মানুহ কম নহয় মানুহ ইয়াতকেও একো আৰু আগলৈ গৈছে ন্যানোটো কিমান 10⁻⁹ যোৱাবাৰ ফিজিক্সত যোনে নোবেল বঁটা পালে আপোনালোকে শুনিছে এট'ছেকেণ্ড স্পেক্ট্ৰস্কপি বুলি কয় এট'ছেকেণ্ড স্পেক্ট্ৰস্কপি মানে আমাৰ এটম আমি জানো এটম এটা যদি লওঁ তাৰ মাজত কি থাকিব ইলেক্ট্ৰন থাকিব প্ৰোটন থাকিব নিউট্ৰন থাকিব আৰু আমাৰ নিউক্লিয়াছটো আমি ধৰি লওঁ হয়নে নিউক্লিয়াছ এতিয়া এট'ছেকেণ্ড স্পেক্ট্ৰস্কপিটো 10⁻18 লৈকে যাব পাৰে 18 10⁻9 হে কৈ আছিলে 10⁻18 লৈকে যাব পাৰে নিউক্লিয়াছ এটাৰ সাইজে হৈছে 10⁻12 মান 12 to 14 18 মানে নিউক্লিয়াছৰ ভিতৰটো আৰু ক'ত কি আছে সব উলিয়াই আনিব পাৰি হেতুৰ কাৰণে যোৱাবাৰ যিটো নোবেল বঁটা পাইছে ফিজিক্সৰ তেওঁলোকৰ নামটো কয় এট'ছেকেণ্ড মানে 10⁻18 সেকেন্ড তেওঁলোকে মেজাৰ কৰিব পৰা যিখিনি স্পেক্ট্ৰস্কপি সেইখিনি এট'ছেকেণ্ড তো মানুহৰ হয়তো কেতিয়াবা আমি আজিলৈকে যিখিনি জানো যে নিউক্লিয়াছ থাকে প্ৰোটন ইলেক্ট্ৰন এয়া তাতকেও বাৰু কিছুমান পাৰ্টিকেল আছে তাৰো ভিতৰত আৰু কি আছে যিয়ে নেকি আমাৰ গোটেই বস্তুখিনি কৰি থাকে হয়তো ইনফৰমেশন আমি পাই যাম আচ্ছা আৰু যদি আগবাঢ়ো এতিয়া এটা বস্তুৱে কম আমি ন্যানো মেটেৰিয়েল বিলাক বনাও কেনেকৈ এতিয়ালৈকেতো আমি ক'লো যে ন্যানো মেটেৰিয়েল বিলাক এইবিলাক যে এটম বিলাক আমি ষ্ট'ৰ কৰি ৰাখিব পাৰোঁ এইটো কৰিব পাৰোঁ কিন্তু সেইখিনি আমি বনাও কেনেকৈ তো বনাবৰ কাৰণে ইয়াৰ আগৰ যিখিনি মই দেখুৱাই আছিলোঁ যে স্কেনিং টানেলিং মাইক্ৰস্কোপ লৈ পেলাই তেওঁলোকে দেখুৱালে বা এইখিনি কৰিলে সেইবিলাক টেকনিকক কয় টপ ডাউন টেকনিক টপ ডাউন মানে আপোনালোকক মই কাহিনীটো কওঁ কেনেকুৱা মানে এতিয়া ধৰি লওক এই কিতাপখন আমাৰ ল'ব পাৰোঁ মই জাষ্ট এই কিতাপখন আমাৰ হৈছে ডাঙৰ এখন কিতাপ দেখ এতিয়া এই ডাঙৰ কিতাপখন আমি ধুনীয়াকৈ দেখা পাই আছোঁ ইয়াৰ থিকনেছটো আমি সবেই গম পাওঁ এতিয়া যদি মই ডাঙৰ কিতাপখন লৈ মাত্ৰ এটা পেজ লওঁ এনেকৈ ইয়াৰ পৰা এই কিতাপখনৰ পৰাই মই মানে কাটি এনেকৈ এটা মাত্ৰ পেজ ল'লোঁ সব উলিয়াই পেলালোঁ এতিয়া সেই এটা পেজৰ মই যদি কওঁ ইয়াৰ থিকনেছটো কিমান কোৱাচোন তাৰ পৰা বুলি এতিয়াতো তাৰ পৰা সবেই আপোনালোকে এটা অনুমান কৰিব পাৰিব যে এইটো হয়তো 2 to 3 সেন্টিমিটাৰ হ'ব কিন্তু যদি এটা পেজ উলিয়াই পেলাই কওক এতিয়া কওক মোৰ ইয়াৰ থিকনেছ কিমান মানুহে তাৰ পৰা পটককৈ ক'ব নোৱাৰে সেইটো থিকনেছ কিমান হয়নে তেওঁ সেইটো আমি দেখাৰ হেৰি তাতোকে যদি আমি সৰু কৰি দিওঁ তেতিয়াহ'লেতো মানুহে দেখা নাপাব তো মানে ডাঙৰ এটা বস্তুৰ পৰা সৰুলৈ যেতিয়া যাওঁ সেইটো কয় টপ টু বটম মানে ডাঙৰৰ পৰা আমি লাহে লাহে সৰুলৈ গ'লো একেটা বস্তু আমি যদি পেজ এটা লওঁ পেজ এটা লৈ পেলাই কওঁ এতিয়া তোমালোকে ডাঙৰ কৰা তো তাৰ পৰা যেতিয়া ডাঙৰলৈ যাম সেইটো ক'ব বটমৰ পৰা আপ মানে সৰুৰ পৰা ওপৰলৈ আৰু এটা ডাঙৰৰ পৰা তললৈ যোৱা তো ফেব্ৰিকেশ্যন যিখিনি আছে আমাৰ নেনো মেটেৰিয়েলৰ সেইখিনি এই দুটাতে মানে কৰে গম পাইছে যে ডাঙৰ এটা বস্তু সৰুলৈ কৰিলো মানে এটমলৈকে লৈ যাব পাৰে আপোনালোকে আৰু এটা বস্তু কি কৰিলো এটমৰ পৰা আমি ডাঙৰলৈ বনালো এটমখিনি লগ লগাই মলিকিউল হ'ল মলিকিউলখিনি লগ লাগি লাহে লাহে আমি এটা নেনোটো কিন্তু এটম বা মলিকিউলতকৈ ডাঙৰ কিন্তু হয়নে atom nanostructures যিখিনি কৈছো আমাৰ atom বা molecule বিলাকতকে ডাঙৰ 10টা molecule থাকিব পাৰে 10টা atom থাকিব পাৰে হয়নে তো nano তো তাতকে অলপমান ডাঙৰ তো এটা কয় ডাঙৰৰ পৰা সৰুটো আমি কওঁ top down আৰু সৰুৰ পৰা ডাঙৰটো আমি কওঁ bottom up oh okay no that is fine so we have basically two methods of fabrication one that is top down where we have a large structures which we reduce to a dimension which is nanoscale that is quite small and the other approach is we start with atoms and molecules and we get the final product as the nanostructures. So these are basically the two ways of getting nanomaterial. Now these are some examples of nanomaterials. Basically nanomaterials are also divided into various forms. For example, this one is called two-dimensional. Two-dimensional means the one condition is that its one dimension must be in the nanoscale. Others can be in centimeter, millimeter, it does not matter. But at least its one dimension should be in nano range. For example, only one sheet, only one paper, right? One paper is what? This is large, right? But the thickness is quite small. So then if it is in the 1 to 100 nanometer this thickness, if we measure, then we can call it is nanomaterial. Now this water bottle, so that comes in the 2D. There I have shown there 2D. You see at the bottom, these are layered like book type structures are there. And second is 1D. 1D you see it is kind of a bottle, right, or a cylinder, but its two dimensions are in the nanoscale ranges, 2 dimensions. And the one is zero dimensional quantum dot. I have shown you. So this quantum dots or this zero dimensional means all 3 dimensions. Suppose this is x, y, and this is z. All 3 dimensions are in the 1 to precisely 5 nanometer range. Okay, all 3 dimensions are in the 1 to 5 nanometer range. Then we call it zero dimensional. So in zero dimensional, there are different structures that we have in zero dimensionals, both organic as well as inorganic. Even some are there that is biologically or naturally available. Okay, so this is how we classify nanomaterial. That means from the same structures, 3-dimensional means it had x, y, and z directions, right? So from the same structures, we have the capacity to reduce it to 2-dimensional, to 1-dimensional, and to 0-dimensional. Same structure, same composition material. So this is the classification. I will give you 2 examples of this bottom up and top down. Okay, the first example is bottom up. I have already said bottom up means we start with atoms, molecules, and then we get the structures, nanostructures. This gentleman is Michael Faraday. We know in our earlier times we did not have this specification that he is physics, he is chemistry, he is mathematics, he is zoologist, or he is botanist. At that time, people used to work as a whole in science. So Michael Faraday is also a physicist as well as a chemist. Michael Faraday. So this Michael Faraday, he was doing some experiment, and at that time, in 1858, there is no such research publication where people normally publish a paper. So what they did, if I discover something or I make something, I have to present before the Royal Society. Okay, all kings, princes will be present there, and all the stalwarts will be present. In presence of them, I have to present what I have made or what I have discovered. When they approve, then they will know that I will get some money for furthering my experiment, or I can even get the credit or the name and fame because those people have credited my experiment. So in 1858, similar way, this is the Royal Institute, Royal Hall. Okay, Royal Institute, this is Faraday. He was giving one lecture. He saw one plate. This plate is original plate by Faraday, Michael Faraday. What he did, he demonstrated to the people that this layer, red layer, is actually gold. So everyone was quite confused and astonished also how that could be gold, because gold people normally know that it is yellowish in color. So this cannot be gold. Then he demonstrated everything. No, it is gold, and its color can be changed, because this is not the simple gold that we make in ornament. This is, they name it Faraday's gold or colloidal, because this is prepared using chemicals. So the chemicals are what? Normally they started with ions, right? Atom, molecule, they combine and they form something. He started with those chemicals and they found it kind of a red color. He named it ruby red. And this ruby red, he presented it to the prince there, who is sitting in the auditorium, and he wrote these things by the prince himself. Faraday's gold given to me himself after his lecture at the Royal Hall. Okay, this was written on that plate by the prince who was sitting in the audience. Okay, that means he got the credit, he got the recognition that Faraday can do such kind of things. Okay, so this is why it is called bottom up, because he started with all the chemicals, with all the ions, right, molecules, atoms, and then they found this red ruby color. Okay, so that is why it is bottom up. Second example I will give you, that is called top down. Top down means, I have already said, that means from large structures I can make small structures. Okay, so in top down, these two gentlemen, they were also in scientific community. You know, most of the movies, when people demonstrate a scientist, how they do it, it is kind of a madman, right? Usually scientists are, they portray in that way that he is a madman, he keeps on thinking like this, because they do such kind of means absurd things. These two gentlemen, their names are Konstantin Novoselov and Andrew Game. This one who is standing, he is actually the supervisor, and who is looking in the microscope, who is looking in the microscope is Andrew Game, his supervisor, and who is standing, he is Konstantin Novoselov. Both are Russian. They do something on Friday night, and they name it Friday night experiment. And they do on Friday night those things which they do not do from Monday to Thursday. And they do all together different things which people normally do not think. Because this supervisor, once what he did, he kept two large magnet and kept one frog in between, and found the frog is levitating, that means he is suspended in the air. Okay, it is quite unusual. Okay, but the problem is he has to take the permission of Animal Ethics Committee or those things, because he is using animal. But what he did, he took some large magnet, and in between the magnet he kept the frog, and the frog was suspending like this. So he named it levitating frog. So obviously when people will see, people will find that he is definitely a madman who is keeping one frog, right? Who is bringing one frog and keeping it in between electromagnet. But that was a groundbreaking discovery, because that also helped you. You might have heard superconductivity, if anyone. Superconductivity means when this electrical wire, some current is flowing, there will not be any resistance. Okay, there will not be any resistance. Because of resistance, we have electricity loss is there. Okay, if there is no electricity, resistance, then electricity can flow. You can get current, means with the uninterrupted current power supply. This also helped in understanding levitation, because you have heard about bullet train in Japan. In bullet train does not go on railway track. Okay, bullet train never goes on railway track. It always go above the railway track. If you try to find in YouTube, it always go above the railway track. Okay, that is because of the principle called superconductivity. It never touches the railway track. Like here what happened? The wheels are going on railway track, but once the train start moving, it try to move away. That is why it can go quite speed, because there is no friction. There is no friction between the train wheel and the train track. Okay, so that this kind of experiment helped him. So similarly, in one night, they again did the Friday night experiment, which is quite different. What they did, you know, this graphite, this lump. They took one graphite lump. So graphite from our school days, we know that graphite, carbon had different allotrope, right? We know that, right? Graphite we have, then diamond we have, right? So what he did, he took one large lump of graphite, and over that graphite, what he did, he kept this Scotch tape, one tape which has high adhesive nature. When it sticks, it does not usually goes away. So he just kept the tape over the chalk like this. He kept it, and immediately he snatched it away. Like for example, this is like sellotape, but the adhesivity is quite strong. So when he snatched it away, he found, and he tried to find what is there coming on the tape from the chalk. When he found that these things are completely different what is there in the graphite lump that he took, he tried to observe it more carefully under microscope, and he found its nature is entirely different from that of the graphite powder. So he did it in the Friday night experiments. He repeatedly did it. He took the graphite block, because in scientific experiment what happened, only one time people cannot confirm that something has happened. If you want to make something remarkable, they kept on doing the same thing. They took the chalk, they took another this tape, they paste it and again scratch it, and they found every time when they did it, they found that something different is coming out on the tape. That material, they name it graphene. Okay, this is a remarkable material. In 5 years, they got the Nobel Prize in Physics. You can understand it is such a remarkable material that they discovered that within 5 years, they got the Nobel Prize. Okay, so this is graphene. Basically, graphene is what graphite we know. These are what? Like this kind of stack thing, right? In school we read that graphite are nothing but the layer of carbon which are stacked infinite. There are a large number of layers. This graphene is only a single layer. That means you see they can keep out a single layer from the stack of everything. Like this I told you, right? These are, for example, this is lump of graphite. There are many layers. These pages are layers. So they snatched one paper. That means what? One layer. So they could do it with the Scotch tape experiment. That is Friday night experiment. Okay. For that they got the Nobel Prize. And this has remarkable application in electronic devices, to medicine, to different field. This graphene. Okay. So this is example of top down. Why top down? Because the lump of graphite is what? This is bulk system. These are many layers are there. From many layers, they keep out one layer only. Okay, that is why it is top to down to small dimension. So this is the paper that is published in Science. Science is a journal which in scientific community is considered one of the topmost journals. So they published it in Science. So this is, I will not go to that. Basically why these different properties happen. Normally what happens that when the size gets smaller, their energy separation, that means they become more separated. Suppose this is like this graphite, they are separated in terms of energy like this. When only single layer, suppose one layer we are keeping out, if the difference between the two will increase in this way. That is inversely proportional. Large number of system, the gap is small. Less number of system means gap is large. So that is basically in physics language that is called quantum confinement. That is coming from a principles in physics, that is confinement, quantum physics and quantum chemistry principles they normally use. So that is coming in physics, so I will not go to. But basic difference I am telling, it is the size and the separation are inversely proportional. Okay. So this is basically color. Why I am showing it, I will go to I will discuss later on. If you can see this is the same material. This is the same material. These are called nanomaterial or nanocrystal, which show different color when light falls on it. Okay, when light falls on it, it shows different color. Do you know any inorganic material which gives you color? Any material which gives you color, which see color? Fluorescent material you have seen, right? Somebody on traffic, they use some light which can be seen from a long distance. So that is what the light is coming from, some fluorescent material. Fluorescent means when it is some current passes through, they give bright light. Okay. Second example, this one. All the LEDs. Now we do not have this yellow color bulb. Do you have? We don't have, right? We all have. Earlier we have yellow colors, that is incandescent bulb. Then we came what? CFL. CFL you have seen? CFL bulb we had. Now we have all these things are LED. Now this LED you are seeing white, but this is not white. This is a combination of RGB. You will find in everywhere this mobile display of everything, that is a combination of 3 colors. If any one of you have know about drawing, painting, your art teacher will tell you RBG, red, green and blue you take, you mix all these things, you can get all the different kind of colors. Okay, so RGB are the primary colors, normally it is same. So this white color is coming from the combination of all this. So why this is coming? You see all the different colors, if you combine, they will give like this kind of bright light, white light. Okay, and these are all nanomaterial. Earlier, if you have noticed, this only 5-watt bulb, LED bulb, can illuminate your entire room. Earlier we used to have 20-watt, 100-watt bulb. So you see 100-watt to 5-watt. Your power consumption is less, but your light is your room is illuminated more, right? So that is one example. That means you do not have to give more power or more energy for getting light from this system, from nanomaterial. That is the beauty, and you can get different color, whatever. Just now I have said, people now we have already RGB, but here you see blue. This is blue, this is slight blue, and this is also light green, right? In that way, you can get millions and millions colors. You do not have to simply stay on RGB. You can get millions color, and if you mix, you can get very bright light. So that is also one contribution of nanomaterials or nanostructured materials. Now, if anyone has read this book, H.G. Wells' The Invisible Man, even if you have heard it, you have heard it, right? Second, I'll give these things. This must be you have seen, Harry Potter. Harry Potter everyone has seen, right? So Harry Potter, have you seen this scene where he puts on the cloak and he becomes invisible? You have seen it, right? Now I am going back to mythology. Do you know this picture? There is a reason why I am coming to this. Do you know this picture? He is Meghnad, this on the sky, whoever is roaming, and he is Lakshman. Do you know the story? Lakshman, Meghnad becomes invisible in air. He cannot be easily detected, and that is why it was quite difficult to kill Meghnad, and he was Lakshman. So why I am telling you all these things, Harry Potter or this thing? They become invisible. How that can be possible? How people can be invisible? So these are mythology or fiction characters. Even if I go to the science fiction, H.G. Wells' The Invisible Man, we have even movies on Invisible Man. But is it possible that a man or a things can be invisible? Now, a material is coming. See, normally invisibility is what? If I see something, if I switch off the light, can you see me? Can you see each other? Suppose it is entirely dark. Can you see each other? Nobody can see, right? Whenever I switch on the light, everybody can see whatever color I am wearing or whatever things, right? But the color difference, you will see whatever you see now outside, the color difference is different. Where what we see is normally the reflection of light that is coming from here to my eye. Is it right? That is our basic understanding we have in our school. Suppose I'm shining a light on him and the light is not reflected back to my eye. Can we see him? Right? You understand my point? Suppose I am shining light on him. Now the light is coming back. Suppose the room is entirely dark, but I am getting a torch, I am shining upon him only. There also you will see, if he is wearing pink, you will not see pink. That you can try. The room is entirely dark, or you are taking a torch and shining light only on one person, suppose. You will see him only. Can you see the person next to him? No, you cannot. Why? Because light is coming to him and reflecting back to my eye, not from him. Right? Suppose the light is not reflected to me. What will happen? I will see this, there are no person sitting there. That is called the invisibility, that is the concept of invisibility. That means light is, they are wearing something which absorbs the entire light or which deflect the light. It will not come back to my eye. So I will see that there are no person sitting there. You understand my point? You understand? If I shine, what will happen? The light will come here. But I am wearing some material. Because of this material or wearing something that does not allow to reflect back the light. It will bend the light on this way. It will bend the light. Okay. So the light is reflected. That means I cannot see the person sitting there. So all of these are fiction. But now it is coming to reality. I am telling you, USA used unseen aircraft on this Iraq and other places for bombardment. Nobody can, even the radar cannot detect this one. Now we have system, this is for light only. In everything we have. Sound also what? Sound is the, if it strikes somewhere and it goes back, right? In submarine also, people are using some submarine which the sonic wave cannot detect if it is going. Similarly, aircraft, if it is going, no radar can detect that some aircraft is going on. And this is for optical. Optical means in the seeing range, because we see range only in the visible portion only. We cannot see UV or NIR, right? Light portion means what? We know that it contains UV light, visible light, near infrared, camera, you have heard maybe, right? Camera which are used in night time, these are near infrared camera, which can easily detect different persons sitting. But for all these purposes, we need the light to reflect back, otherwise we cannot see. But these materials, I will go to that, these are called metamaterials. These are called metamaterials. This has the property that it does not allow the light to reflect back to the person who is seeing. It bends the light. Okay, it confuses the light in such a way that it remains here, it does not go back. So these are called complex system or complex, or in general metamaterials. Okay, so these metamaterials, this I will not go to the physics or this thing behind it. This is the first person, Russian physicist, he first coined. Other things what I have shown, these are mythology and fiction. But in reality, if I speak about the science-based explanation, then this Russian physicist Victor Veselago, he said that this kind of material can exist, which can even does not allow the light to reflect, and a person can be entirely invisible if he wears something made up of this material. Suppose this material is made up of cotton. If I wear something made up of metamaterials, now what will happen? It will not, you cannot see me. Right? Only my head you can see if I not wear something on my head, but other person you cannot see. So this person first said, but everybody thought he is a madman. Normally, because this kind of material has negative refractive index. If physics you have heard, refractive index are not negative, right? But he said negative refractive index material can give you this invisibility concept, means you cannot see. So after that, That is a paper in 1968. When he said it, everybody ignored him. Okay. Later on, John Pandry, he in 1994 again said that no, it is possible. People can do that, but these are all theory only. Experimentally means in reality it was not coming. No person has made metamaterial suit or any cloth. Now these things are going on. Later on, optical clocking with metamaterials. Clocking means the wearing, means the dress. Okay. One paper came there, yes, that can be possible. And when John Pandry saw this paper, what he said, fiction has predicted the course of science for some time. Maybe the Harry Potter novels were ahead of their times. Okay, in Harry Potter, what? He wear one cloth, he became invisible. That is fiction only, in movies only. But reality is coming that no, this can be possible. Maybe after a few years you will see somebody is passing by, you cannot even see him. That can be possible, right? Who thought? I am telling one simple thing. When I was small, maybe Nimalava also saw one television series used to came, Small Wonder. Yeah, maybe some of you have not seen maybe. It is an excellent TV series that is given in Hindi, but it is an original. Maybe it is 1980 or 70 like this. One small child was shown there who can lift everything because she is a robot only. But she looks like human, she talks like human, everything. But she does all the household work. Okay, he can easily lift a bed, she can easily lift a sofa. That we like to see it, but now you see, with AI, people now can make entire human who nobody can recognize that some robot is going by. He can mimic you, he can do everything with AI-based technique, right? Exactly copy of you, a robot will be passing by, you will not understand. So this is the science going. So maybe in 10 years you will find some cloth somebody is wearing that what cannot be visible. But again, science also has, we know, one dangerous aspect. That is a dangerous aspect, right? If something cannot be seen, that can be misused also. So this is another material made up of nanostructures. Why nanostructures? You see the light is not passing by, it is not reflecting. Have you seen? Suppose this is the object, the sphere, light is coming, it is bending nearby, it is not reflecting. So this is the complex arrangement. It is so complex that the light, when it falls, it got confused whether to reflect back or not. It does not reflect back. So these kind of materials are used for making this kind of clock. So basically, metal nanoparticles are different types. So this is gold, right? Yellow one, and this is gold. These are also gold. On the bottom, you see. Maybe you can wear ornament of gold, maybe not of yellow color, but of ruby red color, purple color. Okay, have you seen it? At the bottom, these are also gold. The top one, the Queen Victoria or someone, I don't know. So she is also, this coin is also gold, right? But you can make it of different color when it goes to nanoscale dimension. Okay, so this is the beauty of nanomaterials. And why this happen? Because when light falls, they show this kind of behavior. Okay, when sunlight falls, or if you simply shine one light, then they show behavior. Otherwise, they will not show. Okay, so this is the one example of white also. So coming to characterization of nanomaterials. Now, till now, I'm just asking, because when I made the presentation, I did not have the complete idea of who my audiences are. Okay, it may be mixed people, may not be from the physics or chemistry background, may not be entirely from research. So I tried to make it simple, but I do not know whether you are finding it okay or hard. It is okay? Can you understand?
Yes, sir.
Okay, fine.
I'm very much interested.
Yeah. That is why I have made it without any theory or any equations behind it. but sometimes it is difficult to make people understand what basically I am trying to say. What basically I am trying to say is that these are the advancements of science that is happening in and around us, which we see every day, but we do not realize, right? For example, in your mobile, what you use in your mobile? Your display. Have you seen your display? When we see one mobile, you see some AMOLED display, right? What is this thing actually? We never think about it. What is this AMOLED display? Why this name is coming? TV, even I go to that. TV, Samsung, in TV showroom, you will find OLED TV. Have you seen it? Organic OLED TV, LG OLED TV. People give advertise also. Then Samsung introduced QLED TV. So this QLED is nothing but quantum dot LED. These are all made up of nanomaterials. That's why they show that what you can get a different color. You will not get red. You will get red, slight red, more red, even less red. 10 different variation of red. Earlier only one variation of red you can get. That means distinction of color between purple and near purple can be quite distinct when you see one picture of QLED or OLED, right? Similarly, your mobile you see somebody say, right, their display is quite good. So why this display is coming? When you switch it on, there are all electronic devices inside. But you get, when you take a picture or when you see video, it looks very good. Why it is happening? Because this contains some material which, when you switch on the mobile, what happens? One blue color light appears, right? When this light appears, then you see the screen. When this light appears, it gives you different color because it shines the material in this way. Okay? You see here, this purple, red or ruby red, whatever you are getting or whatever you are seeing, that is under when light shines upon it. Suppose this color, only yellow color is there on your mobile. You will see only yellow. But now you can see what? These 3 different variation of color. So that is the beauty. So everywhere we are surrounding, just we have to understand that sometimes we ignore because we are working on it. That is why we have to do. So it is quite obvious that many things normally we ignore, but all the sciences are behind it. Science and finally the technology. We know that science and technology, these are, without science it cannot be technology. Okay. First you have the groundwork or the fundamental knowledge of a system. Right. Then you can go for a technological application. Now going to characterization. Characterization means how to characterize it. That means suppose this is color it is showing. How do I know that these colors are pure in nature? Milk purity, we know, right? When we say that it is pure milk or not pure milk, what they do, they have some machines that determines milk purity, adulteration, right? We see these things. We speak about these things. But when we go to nanomaterial, how do I understand or how do I know that this color or these things that we are getting, this is coming from gold, not from something else? There may be impurity also during my preparation. Okay, so from there also it may be coming. So this for characterization of nanomaterials, first example I will give, that is called powder X-ray diffraction. So this powder X-ray diffraction is basically, so what happens? Diffraction is what? Diffraction of light. Suppose light is coming like this, it is falling here and it is going to different direction, right? That is called diffraction. That is bending. Somewhere it is bending. For diffraction you need a sharp object. I am shining light, it falls here, it does not pass through, but it goes from different edges to different direction. So suppose I am preparing one material. Now this material I want to know its inner information. Suppose X-ray, you know, from our body we also do X-ray, right? When we do X-ray, we know that in different kind there are fractures are there. If bones are growing or bones are broken, what we do? We do X-ray. Similarly for nanomaterials, whether the nanomaterials are there, whether it is formed, suppose it is made up of carbon material, suppose it is made up of zinc material, suppose it is made up of sodium. How do I know it? Okay, for sodium we have to know that this is sodium. So first we do, this is called powder X-ray diffraction. That means it gives the idea of the skeleton of the material that we are studying, whether this is pure or not, or the related information. So this powder X-ray diffraction basically for nanomaterial and bulk material, I will not go to them, I will just simply define you. So for nanomaterial, basically what happens, for bulk system, bulk means this is not going to the small structures. As usual, this structure, suppose this book. Now when I allow this material to interact with X-ray, we know that X-ray is the one part of the large electromagnetic, means large spectrum of things we know in the solar light, right? We have X-ray, we have UV, we have visible, we have infrared, then we have microwave, right? Microwave we use in home. Why it is named microwave? Because they use microwave radiation, right? X-ray radiation. So these are all radiation, right? UV visible, whatever we are seeing now, these are UV visible radiation. What we do not see, UV light, for example, they say na, ozone layer is capturing all the UV light. So that is UV radiation. These are different radiation. Similarly, for structure, we need X-ray radiation. Okay, so this X-ray radiation, when they interact with a solid system or with a system, for example, with this one, so what will happen? They give us information of the system. Suppose it is sodium in sodium structure. So sodium has some characteristic information. So they will give you some characteristic information. Now suppose if it is not bulk but only this single sheet. Okay, this single sheet information I want to gather. Now what will happen in that case? It will not be, same things will happen, but it will not be sharp. So these peaks actually, have you seen this? In our case, when we prepare, means any company, suppose some company are preparing some nanomaterial, how do they define it? So what they will do, so if it is nano, they will show this kind of broad peak, not sharp. These are sharp peaks, right? Sharp peaks aren't coming. So these sharp peaks are identifying, suppose he is Jodu or Modhu, like this, right? For identifying one man, what I do, that he looks resembles with this one. Similarly, in scientific database, this is called database. This material has some database. People match with it and they find that okay, this matches with X, Y, Z. Now this X, when they become nano, when they become only a single layer, they behave like the sharp peaks disappear and they only this small peak appears. Okay, it will no longer be sharp, but it will be small peak. Okay, so there you have seen this black one. This black one is size is written 1 micrometer, right? Have you seen it? 1 micrometer. Okay. If I go above, you see this is 2 nanometer, but there are no peaks coming there. Okay. So this is actually hard, maybe. In general, the thing is, when we prepare one thing and it becomes so small, it becomes so nano, then its bones are fractured. Simply, I am a healthy man, that means I am not nano. Simply I am just resembling so that you can understand. I am a healthy man. If somebody takes X-ray of me, they will find that his bones are okay, his everything is perfectly alright, fine. Now if some machine squeezes me, you understand? Now it is some machine squeezes me from top to this. Suppose I become like this. I remain like this. My name is this, but I become, after squeezing from this height to, I become this one. So what will happen? When X-ray will fall and they took X-ray of me, they will find that his all bones are broken. Okay? Same thing happens in nanomaterial. when they go from large size from the top to down, top down approach, large size, for example, graphite chalk, right? I spoke, right? From graphite chalk with tap, when they keep out, they found some layered type structures. So with this graphite chalk shows some good large sharp peaks. But when they found identified the tap, they found these are all broken. Broken means they got wide peak. Okay, that is the basic differences. Okay, in bulk system everything is healthy. In nano something is missing. Some bones are broken. So that is identified. First thing is with X-ray radiation. Okay. Oh, I'll not go to that. So this is another technique that is called field emission scanning electron microscope. You have heard about it maybe. You have heard. Okay. This is called field emission scanning electron microscope. Now I am telling you the difference. Did anybody has biology? No. In higher secondary, you have seen microscope, right? Microscope you have seen, all of you have seen maybe. So microscope, what the practical normally people do in higher secondary classes? They do some glass slides are there, they keep some stain, blood stain, right? And they see under microscope, and the practical guide will try to identify whether it is red blood corpuscle, RBC, WBC or something like this. So these are what? These are called light microscope. You know, when we see this, there is something we have to rotate. That is called zooming. Same thing in mobile you use, right? You zoom it to 10x times. It is written, right? When you do in mobile, 1x, 10x, 50x when you take a picture. The same thing. What we do when we take a blood sample, we just zoom it, we see the images larger. That is light microscope. That is one visible light is there for us to see the sample. But these are electron microscope. That means this light microscope can see objects only up to micrometer sizes. Micrometer and nanometer, the relation is 10 to the power minus 6 millimeter, 1 micrometer, 10 to the power minus 9 meter, 1 nanometer. So still 1000 times smaller nanometer. So this light microscope cannot see up to that range. So if you try to see a nanometer, you will see only blurred image. You will see nothing. So we need something. Suppose I have prepared. Now again I am coming to that. Suppose 3 persons are standing. Me standing, madam is standing, and her is standing. All we 3 are different. Suppose X, Y, Z, they do not know how we look like. Okay, X-ray gives you what? My inner structure is good or bad. Whether my things are broken or something like this. Inner structures. But from outer side, how do I look like? Am I tall person, fat person, or how do I look? For that purpose, we need some machine to see the nanomaterial. So these machines are called, one of them is scanning electron microscope. So this scanning electron microscope, they normally what they do, so they give you the pictures of the material that we synthesize. So this is COVID virus. Okay, this is COVID virus, coronavirus, that is taken under scanning electron microscope. Okay, what at that time people showed in TV or something, it looks similar to that. This is just an artistic view, right side. Okay, but the left side is the real image of the coronavirus or COVID virus that is taken with scanning electron microscope. Okay, so this is one picture. So how they capture these things? Now I am again going to some idea of our lenses. This one, lenses. Now for me it is difficult to see you. Most of the people who are wearing specs, they will understand. If I remove it, it is difficult for me to see these things, right? But if I wear it, I see it clearly. Okay, same thing is happening for in higher secondary we have read about this concave lens, concave lens. You have heard, right? Concave, all this. So these are basically what? Glass lenses. Okay, these are glass lenses. We know that when we see under a lens, we see the things either larger or sometimes, if I rotate it, sometimes smaller. The second example, suppose this is your magnifying glass. Magnifying glass can give you a small letter and large view, right? But the magnifying glass can do one more thing. What is it? It can burn things, right? This is our simple experiment we used to do. Suppose sunlight is there, we keep the magnifying glass under sunlight, take a paper at the bottom, it can burn the paper. That means what they are doing? It is capturing the sunlight and it is focusing all the sunlight on a single point, right? Since the energy is so condensed on a single point, the energy can burn the paper, right? The same thing here. Normally, whatever happens, all this optical microscope that we see for seeing the blood sample, they also uses this concave convex lenses. Okay, they just rotate it. Okay, in that way they enlarge the image or reduce the image. Okay, but here the lenses are different. These lenses are basically called magnetic lenses. These are not this kind of glass lenses. These are called magnetic lenses. Because why magnetic? I am telling you. For optical, these are optical lenses only, right? You need light to see the things. But for electron, it has nothing to do with light. For electron, it has nothing to do with light. So how to change the electron? Means suppose the electron is going like this, it has nothing to do with this one, right? You need something else. So we take magnet. So what happens actually in higher secondary, if you have read some physics classes, in physics classes it was given that when electron is passing through a magnetic field, it just changes its path. Okay, it changes its path. Cyclotron was there, Lorentz force was there, right? These things was studied at that time. So the same concept they used there. This electron, you have seen this electron gun is written at the top. Electron gun is something, suppose I am taking a torch, it will give what? Light. Electron gun gives what? Electron. It just bombards electron. Okay, it just bombards electron. And how this electron is bombarded? This electron gun is basically some metal wire. So it is heated to a 1300 to 2700 Kelvin. So at that temperature what happens? It starts emitting electron. Okay, it starts emitting electron. Now when electron will be emitting from there, we need the electron to go on the straight path. At the bottom, have you seen specimen? At the bottom, specimen is written. So we need the electron to go straight path. So how to make it straight? Because once electron moves, it can go here, it can go there, it can go anywhere. How to make them to go in a straight path? That is through lenses. These lenses are called magnetic lenses. So what by tuning the magnetic lenses, they can control the electron to the straight path. Okay, because light we normally know what? Light goes in a straight path. If you shine there, it will not go there. It will go there only. That is why with optical microscope, let's see blood sample only. We do not need this kind of things because it goes straight. It passes through lenses, but it goes straight. But for electron, it will never go straight. It will go here and there. So to make it go in a straight line, we need magnetic lenses. Is it understood? A little bit? Okay. So with this, these are basically magnets through which the electron passes. Here, this is the optical lens. Okay, concave convex lens through which these are light only that passes through. But here it is the electron that passes. Okay, that is the basic difference. Now people can manipulate electron to go anywhere they like through tuning. So this is, I have already told, this is the virus or the coronavirus picture that is taken under field emission scanning electron microscope. You see, these people can take. People can mimic nature synthetically. Okay, this is a flower. Okay, these are all, this is flower, this is leaf, these are flower. And people have made, this is synthetically made similar to the flower, you see. It looks like the flower that they have prepared, but these are synthetically made. Okay, these are all nanoscale material that is of metal. For example, once this AB is of copper. Okay, metallic copper, copper's nanoflower. Second is of manganese. This is of manganese. So normally what we did in periodic table, we cannot even visualize that manganese can get a flower type shape. Okay, only periodic table we read about cobalt, manganese, these, zinc, all these things element in the periodic table. But did you realize that manganese flower I have seen today? Nobody have realized, right? Carbon flower I have seen or something like this. But man-made people synthetically they can make now. So these are all copper, manganese, calcium. The bottom one EFR, calcium. Okay, they are trying to mimic naturally available flowers synthetically in the laboratory framework. These are FSM images. These are polymer, polymethyl methacrylate. These are fibers in chloroform solution. This left side. Okay. These are nanowire they have prepared. These are all polymer material they have prepared. These are nanowire they have prepared. On the right side, if you see, so what they did, they coated this nanowire with polyaniline. Polyaniline is also a polymer. Okay. So they have coated PMMA, polymethyl methacrylate, with pani, polyaniline nanoparticle. So that means on over one, this is one PMMA, over that they have coated some pani. They have some applications, they have numerous applications, but this is after preparation. I told you na. So how does it look? Okay, this is how it looks. So for that purpose we need scanning electron microscope. Otherwise, I have prepared skeleton, I have made that this is manganese. X-ray gives you what? Manganese. So before this copper, calcium, from there it is nowhere it is written, right? It is copper. So how they know that it is copper? They first did X-ray diffraction. From X-ray diffraction they got peaks that are resembling with copper. So they are sure that whatever they have prepared, it is of copper. They got the skeleton. Second, they need how does it look. Okay, for the look with FSM they got that these look like flowers. So this electron microscope gives us images of our nanomaterial. Okay, but one important thing is there. As you can see in this. So how they got this entire image? That is also a very beautiful understanding. How they got this entire image? You see why I am saying this scale, as you can see, this is 100 nanometer, but electron is not that dimension, right? Electron is very small. Electron gives you the picture. How they do? They scan the electron beam. Suppose this is the sample. This is the sample of copper. Okay, I want an image of this copper. Suppose it is a flower. After taking image, I can get it is a flower. What will the electron will do? Electron is coming, it will hit the sample. Now when it hit, now they optimize this. Optimize this means they rotate this sample. Now electron will move like this. X, Y, right? X, in this way it will scan, then again it will scan, like typewriter. Have you seen typewriting machine? What they do this, again they will mark entire things they will do. The same principle they apply. It will read, it will start every point like this. From the image it is coming, right? Then again it will this way, X, Y, Z, X, Y, Z, in that way, X, Y, X, Y, X, Y, scanning they will do the sample. Okay, in that way, whole when the scanning of entire system is done, then they will say it is I have got my image, and that image is only flower. Okay, so this is how they capture the image. Electron capture the images. Next it is there you will see. Suppose from this flower to nanoroll. So how they got this nanowire? Same principle they use. The electron will scan, In every point when they scan, they give you this, that it looks like nanorod in nature. Okay, it is kind of a photography. Earlier we used to have photography, not digital, but we have to clean it in laboratory. Okay, this reel gives you only negative kind of images, but how do you get it? In laboratory you clean it, we process it, and we get the picture. Here the picturing is done by electron only. Okay, that is the beauty. This is second machine that is coming, that is called transmission electron microscope. Now see, the name itself gives that what is the meaning of it. Scanning electron microscope. Scanning means it will scan. So that is why the name is scanning electron microscope. Here also it is electron microscope. Now the name is coming transmission. Transmission means something that passes through. Okay, something that passes through. Now the electron will not scan here. It will just pass through the material. Now when it passes through, the same thing happens. Suppose 1000 electrons are passing through this material, then it will give information of the system. But the difference why it is occurring, it also gives you like skeleton type structures also, because it is passing entirely through me. If my back side is different, suppose SAM gives you only my front side, but back side, whether I am bald, I have hair, or I do not have hair, something like this, SAM cannot give, because it has scanned only my front part. But TEM, what happens, this electron passes through me. So it gives you how it looks like as a whole, means our skeleton also some information I can get. That I'll show you. So that is the difference you see. In SAM, this is the specimen. Have you seen? This is the specimen that is only at the bottom. Okay? And here you see the specimen. It is at the top. So the beam is passing through it. Okay? The beam is passing through and the screen is at the bottom only. But here, specimen at the bottom and the screen is above it. Okay? Because it does not pass through. Now the difference between SAM and TEM you can see here. This is the same sample. On the left side you can see you see that there are silver particles over here? It is difficult to see, right? All over this polymer, PMM nanofibers, these are polymer only. Some particles are there, silver particles. So it is difficult to understand. But this is the TEM image on the right side. Here see, these are the silver particles. Okay, these are the silver particles. That means here it is, can you understand here? It is difficult, right? On the same image, because it scans only. But in this case, it is passing through it. It gives you even smaller dimension images you can see. Okay, with TEM the beauty is that you can see the small dots that are present over a sample surface, which cannot be seen with a scanning electron microscope, because that scans only, and in other case it transmits through it. Okay, so this is the difference. But both of these techniques are called morphology or image viewing system. Okay, these two. There it says that your system look like rod, your flower, or something like this. So from these two techniques, I could understand with X-ray diffraction the basic structure, inherent structure, that I am magnesium, copper, calcium. With FSM, my morphology, how do I look like? So this is another images. In our school days, we tried to visualize benzene structure is this. We drew it, like your graphite is what, six atoms are there in hexagonal or like these things. But that is only visualization or understanding or our idea. But with TEM, these are such a high resolution TEM that gives you every atom, means how does it look like. That information people can give you. So FTIR is basically, again I am telling, this is another important. What is FTIR? XRD you got the skeleton, SAM you got the image. Suppose I am wearing a watch. What are the additional things that I am wearing? Okay, what are additional things I am wearing? I am wearing watch, I am wearing spec, I am wearing a different color shirt. How do I know it? These are called additional adjustment of a human, right? Tomorrow I can, she is wearing different, she is wearing different. but how to identify that she is wearing this one? So this cloth material identification FTIR can give you. Skeleton I have got. So suppose this is made up of cotton. FTIR will take, it will give you some vibration that matches with the vibration of my cloth. There we can understand. Suppose I am wearing this watch. So the watch information, they will give some another characteristic vibration. Now here you see one thing. In X-ray, what frequency, what wavelength we use? X-ray, right? For UV visible, what? UV visible. Here what we are using? FTIR, IR radiation we are using. Okay, here visible, because what IR radiation are? You see here, IR radiation energy is very small. That means its wavelength is very high. This is IR. This is UV visible. UV visible range, what we see is normally only the 400 to 700 nanometer in that range. So we need IR to see the vibration of a molecule. Vibration cannot be obtained from UV visible, X-ray or those spectroscopy. X-ray gives you diffraction, UV visible gives you color, how it looks like. That FTIR gives you vibrational spectroscopy. Okay, so this vibrational, as I have told, suppose I have prepared, this is instrumentation, I will leave it. Suppose this one. Suppose a polymer has carbon-hydrogen bond. It has carbon-oxygen bond. Okay, or it has some other functional groups. Functional groups, as I have already said, cloth or watch or something like this, but over a system. So how do I get? When we take the FTIR, or when we shine or interact, allow the interaction of infrared radiation with my molecule, what will happen? Different molecule, different this functional group or the CH, CO, they vibrate at different frequency. So they will give one spectrum which is characteristics of CO bond, CH bond, CH2 bond, and these things. Suppose it has only two atoms, carbon and hydrogen. So what understand we get? That this hydrogen and carbon may be stretching like this, right? Only one possibility is there. Either it is stretching out or it is coming in. Okay, only two. Suppose it has three atoms, hydrogen, oxygen, hydrogen. Suppose water like. So it can, this is fixed, it can move like this. This side also can move like this, and this can even bend, right? So one is bending, one is stretching, and stretching, if it is, for example, from oxygen, it is equally stretched. This is symmetric stretching. And from one, if it is small stretch and one is large stretch, it is asymmetric stretching. Even along with that, we have rocking vibration, wagging vibration, all these things of vibrations are there. If it has different polarity, suppose oxygen, carbon, hydrogen. So what will happen? Oxygen and hydrogen has different polarity. In that case also, when light infrared radiation will interact, they will show some different vibration. So because of this vibration, they will give FTIR peak at different position, at different frequency. From there, we can understand. So here you have seen on the first picture, it has different CH groups are there, right? It has different CH groups, but all these CH groups, if you can see, it has antisymmetric banding, and it gives you the different vibrations. Okay, I will go 5 minutes or 3 minutes break. I will take to have a cup of tea, if it is allowed. I'll need only 1 or 2 minutes, so if you can stay, I'll finish it. You are going?
Stay for 5 minutes.
I'll just finish it. It
Sir,
will not take a long time.
तुम लोग ना 5 मिनट बैठो, सारा कंक्लूजन मतलब फिनिश नहीं हुआ ना।
to the ending. So these are all polymers. As I have already told, these are showing a different position, different frequency. I'll just fast forward it a little bit. I took many things. I don't know whether BT surface area you have heard. So this gives you the surface area. Surface area means, suppose I'm a small person, I have a different surface area. The big person is saying they have different surface area. So how I can take the surface area into consideration for manipulating or for doing some reactions. Okay, most of the reactions are surface phenomena only. More surface area, that means I am exposed more for chemical reactions. That is one understanding. So that is BT surface. So how do I know that it has small surface area, it has large surface area? One basic example I will give. You have heard carbon, activated carbon you have heard, that are normally used for filtration. Okay, even your aquaguard has this activated carbon present there. Okay, so this activated carbon, how do I know that how it absorbs high surface area? For that purpose, we need this kind of machine, that is BT surface area analyzer. So I'll not go to that, so many technical things. So this is basically how we can know the surface area of a material. Zeolite, have you heard zeolite? So zeolite is normally have a surface area of 585 meter square per gram, whereas activated carbon 1053 meter square per gram. High surface area, that means we can use it better for filtration. Because for filtration what happens, it has to absorb all the ions. Suppose lead, in water you have lead, cadmium, all these things are there. It should absorb, or any unwanted things that are present in water. So it can absorb easily. It has high absorption. So that is why activated carbon is preferably better than zeolite. So these are some examples. So this, in the very beginning I told you about OLED display or these things. So these three gentlemen in 2014 got the Nobel Prize in Physics for discovering blue LED. Okay, so this kind of TV you have seen, I think. You have seen, right? All this kind of TV. You are coming to this generation 2010. So how it is coming? Because of nano, you see this display on the very right bottom. It gives this much variation in color. That is why quantum LED TV you have heard Samsung, or OLED DVD of LG. Why it gives entirely different display? Because of the use of quantum dots. Because this 1 to 3 nanometer variation of quantum dot in a small size can give you large variation in color, beautiful color. Then second, storage. Storage, all these devices you see, the bottom one, very left, this is 8-inch hard disk of only 64 MB. Okay, now you take a hard disk of what? 1 TB, 500 GB, that is this, introduced by IBM in 1979, that has only 64 MB. Okay, floppy disk, maybe you have not used floppy disk. Okay, initially in our PhD period, you used to have floppy disk only. Okay, later on this pen drive came. So only few KB, only 1 or 2 file only you can get. In chemistry, this FTIR had this floppy disk. Okay, so from there you see in 1999 IBM introduced this pen drive. This pen drive has a capacity of what? Only 8 MB. Can you realize? Now a photograph has a size of more than 20 MB, right? This pen drive has a size of only 8 MB. You cannot carry many things over it. Now we are going to a size dimension Intel. You see, this is, now we are getting 1 terabyte hard disk, and that you can easily keep in your front pocket. You do not need large space. Now the revolution, you will see where it is coming. These two gentlemen got the Nobel Prize. Why? They discovered something that I told you, that in small size how to input more knowledge. Okay, a hatimari buruka bhorwa nisina. Small space, how do I incorporate more knowledge in our small brain? Okay, in computer you do the defragmentation, right? So that you can input more data. The same thing this is the latest work where they have shown that 502 terabyte, not even 1 TB, 502 terabyte information you can store in 1 inch. Okay, in 1 inch. So your mobile will be this much, but you can copy your 502 terabyte data in your system. But this is still not commercialized. One difficulty is there. These things works at 77 Kelvin. 77 Kelvin, you understand, right? Much lower, not at room temperature, simply 77 Kelvin. You need liquid nitrogen temperature to work. So that is not commercially, practically feasible. Okay, but still people are trying. You see, if that becomes possible, only one in small pen drive you can keep in your pocket, and entire universe is on your pocket only. So you see what Richard Feynman told. Can you write your 24 volumes of Encyclopedia Britannica on the head of a pin? Now in 1 inch, they are carrying 502 terabyte. See, it is becoming reality in the information storage. And in front of our eye, these are happening, right? Mobile and all these things being done. So this is the reality. With this, maybe I'll just speak what I do so that you can understand. I try to run car with water. That is what I do. I try to run car with water, okay, instead of your petrol or diesel. Okay, I try to run car with water. Simply how it is done. Have you heard about electrolysis of water? It is in our school days, right? Water is easily split into, you put some voltage, water is dissociated into hydrogen and oxygen. Okay, so this is green. Otherwise, whatever petroleum products we use, it has associated what? Carbon dioxide as an emission, which is harmful. But when water dissociates, it gives you only hydrogen and oxygen. So I try to dissociate it in your tank, and then your hydrogen is generated. That hydrogen, when it burns, it gives you enough energy so that your car can move. Not only that, in many industries or this is where coal or other petroleum things are used for energy production, that can be replaced with water or simply hydrogen.
I think if you are having vacancy in R&D position,
so that we are trying, but this is again what Feynman told, that is his dream, but it took time. This is what not only me, many people around the world they are doing, but it is still hydrogen car is not running. Hydrogen car is there. If you go to Europe, there are hydrogen car, but those are produced from suppose methanol or something, but that again when it is dissociated, it requires very high temperature, 1100 degrees Celsius, 700, that is called thermochemical decomposition to generate hydrogen. That is not feasible actually. But this is simply you need one small voltage, and this is two ways you can do. You can put a battery, it can be dissociated, and you put sunlight, it can be dissociated. For that purpose, one thing they need, that is called catalyst. Catalyst that can reduce the energy barrier. Okay, so in that way what will happen, a small energy input is needed so that water can be dissociated into hydrogen and oxygen. Okay, so this is what normally I do. Oh, again this video will not be played. This is already hydrogen generation, I just showed you. So this video will not be played, but luckily I have brought the video only. Just one small clip, so that you can also get an idea how do we generate it. If it is open. That is the measurement, whether hydrogen efficiently it is generated. All the bubbles, can you see? The bubbles. The bubbles, can you see there? So these are hydrogen, we know these are very lightweight. Okay, when dissociated, all the bubbles that are, you see, these are forming.
So this is all water.
These are all water.
Water and your catalyst.
Your catalyst. This is working, this is platinum electrode, this is working electrode. So obviously, usually what happens, platinum is cathode, so hydrogen is deposited there, but this catalyst reduces the energy for hydrogen generation. This one is my electrode, in the middle, this one. And hydrogen is generated on the right side, that is platinum. So this is one picture of my work. With this, thank you so much. Actually, we people have a habit to give lecture only before research scholars. So that is why I do not know whether I could, because you are not all means from the same background or from, for example, for research they are doing. So I do not know how far I can make you understand the fundamentals of nanomaterial, but I have tried, and thank you so much for this time.
Thank you, sir. Thank you for this session, because it enlightened all the participants present here. No? Though it is multidisciplinary, but the lecture is very interesting. So if there is any question to ask to sir, you can. If anyone is having any questions or anything to know.
If no, then I have one question. Just a small question. Okay, hydrogen is prepared, then it takes a large volume. How will it keep in a cylinder?
Oh, actually, hydrogen, there are three basically
There was
stages.
one
Now,
cylinder.
there are
Yes,
three
I see.
stages. Actually, one is generation, one is storage, and the third is transportation. So that is why it is not commercialized, I am telling you. Because when hydrogen will be generated, the main difficulty is there. Water, when it dissociates, easily again recombine. We have to separate, means keep the hydrogen out. So for hydrogen keeping, hydrogen, you know, it is highly explosive. So it is kept under some sodium, it is called hydride. Hydrogen is kept in form of hydride. So it is not nascent. In nascent form, it will not be stored. As a hydrogen, in hydrogen form, it will not be stored, but it will be reactive in storage purpose within some framework material, storage material. So that is basically hydride, sodium hydride. So when electricity will be there, hydrogen will be dissociated, and that time it will run. But for now, what is happening? People are trying, instead of going to that stage, directly from water. So what basically happens? They inside the fuel. Suppose car is running. Now inside the car we have all the fuel devices, petrol, if there is gasoline or LPG. Now inside the system itself, when hydrogen will be generated, hydrogen and oxygen will be generated in two different compartments. Hydrogen will be directly, it will, since it is lightweight,
That is
it
the
will be carried.
fuel cell technology, you know, I think hydrogen fuel cell. Similarly, no, that storage of hydrogen and oxygen.
Hydrogen. So it will be carried and it will be immediately combusted by the driving engine. So it will be combusted and it will run. So what will happen during combustion? Since oxygen is there, some energy will be generated. Again, it will be recycled. It will take atmospheric oxygen. Okay, it is combusted. So after combustion, what will happen is it will again react with, it will take up atmospheric oxygen, and again it will become water, moisture. So in that way, it will be recycled. People are trying to recycle it. Otherwise, the usual steps are generation, storage, and transportation. And it is not easy to transport hydrogen because it is highly nascent form. You cannot keep hydrogen out because it is kind of an atomic bomb. Hydrogen more dangerous than the LPG cylinder that we have in our
Compressing
home.
and keeping is very.
Yes, to make it compressed and then to transport, it is not that. That is why they are trying. So how to reduce it by driving the system inside the car, but it is not that much easy because there are several factors that are coming into play. Safety issue is there, another issue. So all these things must be sold so that it can be commercially used. Technologically, sometimes what happens for us, we are basically trying to figure out the science behind it. There are some people who are working on the fuel cell technology. They will think about how to have the device, how to do this. So there is entirely a different sector. We'll see about the technological point of view. We are trying to prepare one catalyst. We are working on the catalyst part.
Mainly the
Catalyst part, so that it can efficiently help in the generation of hydrogen. But after generation, how to take it, where to store it, how to, so that is one entire group of people are working on storage of hydrogen. I am working on generation. One group of people are working on storage of hydrogen. What are the different storage material? So this catalyst may not be a good storage. We need a different storage. Now that is why people are trying to make material which are generator as well as it can store also. So we do not have to take two different material. One can generate, one can store. So the same material can generate and it can store.
simultaneous generation and storage.
Storage. The same thing is coming, even carbon dioxide. You know now methanol has been added. All the cars, right? Some 20% ethanol is there. Now somebody is trying to capture directly carbon dioxide from atmosphere and carbon dioxide from air, so that it can be converted to methanol or ethanol. These are called value-added fuels.
Even the methane.
Methane, even the methane. So they are trying to produce those kind of things.
Thank you, sir. So with this, we have concluded the second technical session. And tomorrow again we will resume our second day session, and it will start from 9:30.
Oh,